In this video, Gauss Law takes center stage in electrical engineering. Viewers will dive into the essentials of this powerful principle, starting with its formula. Imagine a spherical system. Gauss Law simplifies electric field calculations by relating charge to flux. The video breaks down how to apply Gauss Law step by step, making it easy to grasp. Why is this important? Understanding Gauss Law helps engineers design better electrical systems, from capacitors to circuit layouts. If you've ever wondered how we calculate electric fields or why charge distributes the way it does, Gauss's law is the key. By the end of this lesson, you'll understand what Gauss's law is, how it works, and why it's so useful in engineering. Let's get started. What is Gauss's law? First, let's define it in simple terms. Gauss's law tells us that the total electric field passing through a closed surface depends only on the charge inside that surface. In other words, if you enclose some charge inside an imaginary surface, the amount of electric field coming out of that surface is directly related to the total charge inside. Mathematically, it looks like this. But don't worry too much about the formula right now. Let's break it down in a way that makes sense. Imagine we have a spherical surface with a charge at the center. The charge creates an electric field that radiates outward in all directions. The surface we choose is called a Gaussian surface, and in this case, it's a sphere with a radius of 1 meter. According to Gauss's law, the total electric flux through this spherical surface is directly proportional to the charge inside it. The law can be written as, where we have the electric flux through the spherical surface. This is a measure of the number of electric field lines passing through the surface. Total charge enclosed by the surface. This is the charge inside the sphere, e.g., a point charge at the center. Permittivity of free space, a constant that measures how easily electric fields can pass through a vacuum. To understand how the electric field behaves at a point on the surface, 1 meter away from the charge, we use Coulomb's law. The electric field at a distance or from a point charge Q is. At 1 meter away, this formula tells us the strength of the electric field at that point. Since the charge is symmetric and the electric field lines are evenly spread out in all directions, Gauss's law helps simplify calculations by focusing only on the enclosed charge, not the details of the distribution. This makes it easier to compute the electric field and flux, especially for symmetrical charge distributions like spheres.